Hi students, let's look at this question here, which is functions, taken from the year 2015 paper 2 question 3, which is from the A-level Singapore A-level paper. So the function f is defined by f 1 over 1 minus x squared, and is x bigger than 1. Show that f has an inverse. I think this first part is pretty okay. Just need to draw the graph using your GC, right? So what we get is essentially we need this graph here, x bigger than 1. So go to the y-axis here, then we just key in this 1 over 1 minus x squared. Okay, then the domain, remember when we do x bigger than 1, just put a divide sign and put x. Second test, put it 4. So I'm going to key in the domain here 1. Okay, usually I'll just ask students to keep putting an equal sign because it's important. Sometimes you need to know which point it corresponds to. So just key this in. I'll get this graph here. Now, of course, we know there's what they call it, the vertical asymptote, right, where x equals to 1. So here, what we do is 1 over 1 minus x squared. I would suggest we just write vertical asymptote. We just know that 1 minus x squared equals to 0. So we know that x is equals to plus minus 1, right? Then, of course, the horizontal asymptote, we also know that y is 0. There's a horizontal asymptote. So when we sketch a graph, it will just be something like that. Okay, so if you're not too sure, what we can do is just zoom box to the area there and see if it touches the across the x-axis. Okay, so here, go over here, zoom to this area here. Okay, so this is the graph we're looking at. So it looks something like that, like a reciprocal graph. Is x equals to 1. Okay, then what we need to do is just show that the horizontal line cuts the graph at most once, so it's a 1-1 function. Does the f inverse exist? So we just write the arbitrary line y horizontal line cuts a curve at most once, so thus f is a 1-1 function, hence f inverse exists. Okay, that's pretty much okay. So then we find f inverse x and state the domain. I think this is also pretty much okay. F inverse, we just let y be the equation of the curve, then we make x a subject, right? So this case here will be 1 minus x squared equals to 1 over y. Then from here, we know that x squared is equals to 1 minus y squared, 1 over y. Then x is equals to plus square, open square root. Either this is 1 minus 1 over y, or x is equals to negative 1 minus 1 over y. So we need to reject 1. Of course, we reject the negative 1 because x is bigger than 1. So reject as x is bigger than 0. Okay, x is bigger than 1. Okay, so there's that. So hence f inverse x is equals to square root 1 minus 1 over x. The domain of f inverse, is the range of f, right? So the domain of f inverse is the range of f. So in this case, the range of f is just negative infinity to 0, not inclusive of 0. So there you go. So hence, and the domain of f inverse is negative infinity to 0. That's pretty okay. Done. So we've done the first 2 questions. Then we look at the part B, which is the function g is defined by this new function here. So similarly, what we're going to do for part B is to just sketch this curve here and try to understand what's going on. So I'm going to just remove, this is all real valued, which is pretty good. So 2 plus x, let me just put this 2 plus x over 1 minus x squared. Okay, then I'm just going to zoom standard graph here. So that you can see that there's a minimum value here. So we can zoom box, a lot of underutilized space here. If you're not very sure what's going on, you can just zoom box here. Then just scroll all the way up. Okay, so this is a graph here. Great. You see that it cuts, right? You see that it cuts up, it goes up and go down again. So if you go to window, I could just examine. I'll just put a negative 10 just to expand. You see this? It goes up. There's a sort of like a maximum point there. It goes up. Then after that, it goes down again to 0. Okay, so that's going up and coming down this side here. So when you sketch this graph, just be mindful of that. So try and understand what's okay. The graph is not part of the solution, obviously, but try and understand what they're trying to ask. They're asking us to find actually the minimum point here, right? Basically, what we want is the range of G, which is this guy here. Then there's another maximum point here. So this is the range of G, okay, that we want to find. Obviously, there's a vertical asymptote is when this equals to 0. Okay, so that's why we all get x equals to plus minus 1 here. Okay, great. So how do we do that? Actually, when you want to do this question, it's a very standard question where we talk about discriminant because, okay, first off a glance, it's not really a discriminant question, but what we want is actually the horizontal line here touches the curve. It also rather the y value can exist. Okay, so essentially you want the horizontal line to touch it at most once, then once, just exactly once, that will be the y value there. Or you can just write basically you can cut twice, but you do not want the y values do not exist. Okay, so that's the way to think about it. So somewhat basically what we're gonna do is just gonna take when y equals to a value. So I'm gonna just write let horizontal line be y equals to a. Then what I'll do is I just sub y equals to a into the equation of the gx, which is 2 plus x over 1 minus x squared. Okay, then just solve this. All right, then once done, we just cross multiply. Now we want this to have real solutions, okay, because we want it to intersect. Now you know it's discriminant because this is being reduced to a quadratic equation, not because you know from the get-go, but it's because when you solve this equation, this is quadratic. That's why we use discriminant. Okay, so what I'm gonna get is a minus ax squared equals to 2 plus x. Then this is ax squared plus x plus 2 minus a equals to 0. So since we want y value to exist, so it means we want real solution. Okay, so real solution exists just means discriminant must be at least 0. Okay, so then this will be b squared minus 4ac, which is actually the 4ac, which is 2 minus a, at least 0. Then I'll solve this. This will be 1 minus 8a plus 4a squared, at least 0. So 4a squared minus 8a plus 1 equals to 0. Not an issue. Then just solve this quadratic equation by using minus b plus minus b squared minus 4ac over 2a. Okay, so just solve it. This will be key in calculator. They want exact value, so this is 48 over 8. So 48 could be divided by 16. So this is minus 8 plus minus 16 multiplied by 3. That will be square root minus 8 plus square root 16, which is 4 root 3 over 8. Okay, so then you just simplify this is minus 1 plus minus root 3 over 2. Great. Then once you're done, basically when you solve this inequality, it looks something like that. Here is a. So this guy will be minus 1 plus root 3 over 2 minus 1 minus root 3 over 2. Okay, so you want it to be positive, so this region that you want to take, so hence a will just be at most minus 1 root 3 over 2, or a has to be more than minus 1 plus root 3 over 2. What you need to check is that this value here using a GC, it corresponds to the value that we just found. Okay, so this value here should correspond to minus 1 plus root 3 over 2. So you key in minus 1 plus root 3. So root 3 over 2 minus 1. This is this over here will be, sorry, there's a careless mistake. Minus b is plus. That's why check your answer is important. Okay, so this is minus b, so this is plus, so this is plus 1. So this is 1 plus root 3 over here. Then this guy will be root 3 over 2 minus 1. Okay, so let's check your answer. Always check your GC. So basically your value here, your max mean point here, let's say we find the minimum point, or let's find the maximum point here. Calculate maximum. 4, then you go to the other side. Scroll to the other side, let's say here. Press enter. There will be 0.133974. So just key in calculator and check if it corresponds to this value here, the y value. All right. So the y value is this. Yeah. So it's 1 minus 1 minus root 3. Yeah, 1 minus root 3. Just make sure you minus root 3 over 2. Okay, great. So that's how you do this question here. So thus hence the range of g will just be from negative infinity to inclusive of that point, which is 1 minus root 3 over 2. Then union with 1 plus root 3 over 2 to infinity. Okay? So that's how I do this question here proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.